Before we can start milling anything, we need to make sure that we have the correct tools. To do this, we'll import the Innovation Center tool library. This can be found on the Canvas page under Pages, CNC Mill Tormach, under the Aluminum Tool Library file. Once downloaded, you'll go back to Fusion, click on Tool Library, right-click on Local, and it'll give you the option to import the library, where you'll put in the file that you just recently downloaded. From there, it should give you access to all of the tools within the Innovation Center's aluminum library. Once the tools are set up, we need to develop our axes. So once in the manufacturing package, we'll get the option here under Setup to change the axes. So this box represents the stock. We want the axes so that the y-axis is pointing backward, the x pointing to the right, and the z pointing up. To do so, we'll go here under Orientation, select Z and Y-axis. The Z-axis can be selected by clicking any of these vertical bars, and the Y-axis by clicking this bar. Now, we want this to exist on the top left corner so that the mill understands where the origin is. The box point and this top left point. The first process that we're going to do is a 2D face. We found under 2D, the face. I'm going to open up what I've already created. The tool to select is going to be the 1-inch MiniShear. Once selected, click OK, and it should default to these lines here. We'll simulate. And it should only take the top surface off of the stock. Next, we're going to do a 2D contour. 2D contour can be found under 2D, and 2D contour. Again, I'll open what I've already created. Your tool will stay the same. Your geometry, you're going to select this bottom edge. Heights shouldn't change. Under passes, though, you're going to go down to multiple depths, select the check mark, and under maximum roughing, you're going to click and enter 0.1. Then move down to stock to leave and click 0.01 for radial stock to leave and 0 for axial stock to leave. Here you should click ramp if not already selected, and 2 degrees should be fine. Then we'll simulate. And this is just going to take all the walls off. Next, we're going to do a 2D pocket to create the handle. We click under 2D, 2D pocket. Your tool will stay the same with the 1-inch flat. Geometry selection will be this face. Heights will not change. Under passes, go to multiple depths, again, type 0.1 inches, and under stock to leave, type 0.01. Once finished, we'll simulate. And you want to make sure that it's taking off a small amount every time that it passes. We don't want the tool to plunge all the way through the aluminum because it could damage the tool. You want to check for these columns followed by these yellow passes here. Next, we're going to create the cylinder. To do so, we're going to open up another 2D contour. The tool will stay at the 1-inch flat. The geometry to select will be this top edge. And under heights, we're going to change the bottom height to a selection. The selection that you should make is either this edge or this face here. Passes, multiple depths, 0.1 inches for maximum roughing, stock to leave, 0.01 for both. Check here that our ramp is set for 8 degrees this time. And we'll simulate. Next, we're going to do a finishing pass, which means the last pass to take before we have our actual part, or at least the surface of the part. To do so, we're going to click on another 2D contour. It'll follow the same operation as before, except for we're going to change the tool to the 1/2 flat end mill. Your geometry again will be this top edge. The height, again, on the bottom height will be the selection of this face. you'll click multiple depths, 0.1 inches. But this time, we don't want to leave any stock. And again, change the ramp to 8 degrees. And we'll simulate. It should look similar to the previous operation, but it will take off just a small amount to clean up the edge. Now we're going to do a finishing pass on the profile at the bottom. Again, another 2D contour. Again, the 1/2 inch flat end mill. The geometry will be this bottom edge. Under heights, for top height, we'll click selection. Top reference will be this face. Again, multiple depths, 0.1 inches, and no stock to leave. Adjust the ramp to 8 degrees. We'll simulate. Now we're going to do the finishing pass on the handle itself. To do this, we're going to select the 2D pocket. The tool will be the 1/2 inch flat end mill. The geometry will be this face. We won't do any of the multiple depths or stock to leave, and we won't adjust the ramp this time. We'll simulate. Next, we're going to mill the hole in the center. To do so, we're going to click under Drill. The tool will stay as the 1/2 inch flat end mill. The geometry will be the inside surface of the hole. Under Heights, we want to change the top height to stock top and the bottom height to whole bottom with an offset of -0.01 so that it passes through the model. Under Cycle, we're going to click on Bore Milling, and under Diameter, we'll type 0.625 inches to match the diameter of the hole. We'll simulate. Next, we're going to mill out each of the holes. To do so, click under Drill. The tool is going to be the 3/16 drill here. The geometry, will select the inside face of each of the holes. We won't adjust the heights. And under the cycle type, we'll click Chip Breaking Partial Retract. We'll simulate. Now we're going to carry out the socket milling of the inner piece. To do so, it'll be a 2D pocket. Change the tool to the 1/4 inch flat end mill, listed here at the top, tool number 2. Then under Geometry, we'll select this face. Under Passes, multiple depths. This time, we'll change this to anything less than 0.083 inches. Now, under Ramp Type, we'll click Pre-Drill, and it'll give us the option to select the pre-drill. And you'll select this edge. And we'll simulate. The final piece will be to mill out the small hole at the other end. Again, click under Drilling. Select the inner face as the geometry. The tool will remain as the 1/4 inch flat. Under Heights, you'll select this top height and click Selection. The top reference height will be this line here. And there'll be a 0.1 inch offset above that line. Then under Bottom Height, you'll keep whole bottom, but put a -0.1 inch bottom hole offset. Under Cycle Type, Bore Milling, and the diameter will be 0.375 to match the diameter of the hole. And we'll simulate.